Good morning, everyone. Thanks for coming to our Weed Science webinar series, Training of the Next Generation of Weed Science. Today is our great pleasure to have here Dr. Tom Mueller from the University of Tennessee. Dr. Mueller is involved with weed science for a long time, and he can add on that later on. And it's great to have him here with us. Today he'll be talking about Dicamba off-target movement in the United States. Dr. Tom Mueller, it's a pleasure to have you here. Thanks for accepting our invitation. And I'll turn back the screen to you, and looking forward to hear your talk.
Okay. How does that look?
It's not on here. No.
Is it on? I'm seeing it very well.
It's not. Let's see.
Let me zoom in again.
Did you push share screen? But
I'm joining the meeting again.
all right. So let's wait a bit. We are having some issues. Okay.
Okay, now I'm in. And I want to share screen.
Share screen.
Okay. How's that?
I think now it's going to be on. Yes.
Okay, so now I'm going to go to full screen.
Just the presentation.
How does that look?
Okay, it would be better if you go to display settings and make it.
How about that?
Yeah, perfect.
Okay, well, all joining us today, I apologize for my clicking the wrong buttons. I am very happy to be here today from Tennessee. Before I begin, I have been in Brazil before, and I have a little token of my time there. It was a very lovely place to be. Before I begin, I want to talk to you about the most important thing in my life right now is this little baby, my grandson, and I understand that people have affections for their grandson. This is my first grandchild, and it is the most beautiful child in the entire world. And I'm very happy that he has come into our world. And this is a picture of my wife, who's downstairs. So if you hear a little screaming in the background, it's my grandson who is here today. I'm very happy to talk about our data. We have an extensive amount of data. We have about 30 minutes that we wish to cover. We have field data, including field surface condition, dicamba formulations, and the effect of rainfall, which is going to be a very important thing if this product is ever used in Brazil, and I want to focus on that. We have a large amount of laboratory data, especially looking at the effect of pH on how this behaves. And then I want to close with some more philosophical talk about what we in America are suffering called dicamba fatigue, and a few closing thoughts, including some very recent developments on this topic. What I am not going to cover today is extensive vapor pressure calculations, Henry's law constants, which are very important aspects of the chemistry of the mixtures. Inversions, or how the atmosphere can affect particle drift, and no acid-base equilibria concepts. And I know Dr. Ed Camargo is very disappointed that I'm not covering any of this information, because he just loves chemistry, just loves chemistry. So Ed, I'm sorry, but nothing of that today. I do want to be very clear, and that we are being recorded today, that the views and ideas expressed in this presentation do not represent the views of the University of Tennessee, my Department of Plant Sciences, my state regulatory agency, which is the Tennessee Department of Ag, my primary funding sources, the Tennessee Soybean Promotion Board and the United Soybean Board, and the mention of a product does not constitute endorsement of that product to the exclusion of other similar products. And some of this data is unpublished. In fact, much of it is unpublished, and so therefore still subject to interpretation. While I have all of you on the line, if you ever get bored, I wrote a book. It's a wonderful book. It's a fantastic book. But unfortunately, it costs way too much money, so no one buys it. So, I mean, it's there. I just want to do that. The first idea I want to share with you is contrasting particle drift and vapor drift. In both of them, the herbicide is not staying where it's supposed to stay. In a particle drift situation, the droplet never hits the target. It's windy, your boom is very high, I spray with flat fan nozzles, and the wind blows it directly off the target. With vapor drift, the droplet hits the target successfully and then moves later, often through evaporation or perhaps physical movement of dust or particles off the treated surface. Now, what does this mean with respect to the labels? And a label is in America, we call it, a label is the use instructions of how to correctly use a pesticide. It's called a label. Well, particle drift, I can write labels to protect from particle drift. Keep your boom lower, use coarser nozzles, don't spray into inversions, those types of things. So I can effectively reduce particle drift by labeling. With vapor drift, it's a different scenario. And if something really is volatile, it's really basically very difficult or impossible to write a label that will disallow if vapor drift is a primary loss mechanism. So that's one of the big differences there. There's a lot of recent effort on emissions of dicamba under field and lab conditions. And the reality is all herbicides volatilize to some extent. All herbicides at a small amount or a large amount evaporate and move. The most common example of a herbicide with very low volatility is Roundup or glyphosate. And glyphosate by itself has a vapor pressure and a use pattern and so forth. That's very low emissions from vapor drift. I show this particular slide because this is a paper that was published in 2013. It has two co-authors from Monsanto. Dan Wright is an excellent chemist, and Kirk Lamont is an excellent statistician. And it was a nice paper. And I only show this because I've been doing this research since 2009, 2010. And basically since that time, I've been doing dicamba research under field and lab conditions. So this is not something I've entered into recently, but have done for quite a long time. Through this presentation, I will use the terms DGA salt and so forth to designate the formulation. So the older generic, if you will, salt is the diglycolamine. Monsanto took that same diglycolamine and added vapor grip, which is an acetate pH modifier, and it's going to be DGA plus VG. And then BASF has a new product, which is a new amine salt. It's a different salt with lower emissions. I think it's interesting to note that all of these are water-based formulations with amine. So there's actually quite a bit of similarity between all the formulations with respect to how they are actually formulated. Now let's get into some of the field data. This is a small tractor that is used to spray our field plots. It's about 10 meters wide. It's got drift reducing nozzles and so forth. And this happens to be a soybean field in one of our trials. The first field study I wish to discuss is how does surface condition affect dicamba volatility? And we generated three types of surface conditions. We had tilled ground, which basically had no plant residue, dead plant vegetation, which we sprayed with paraquat a couple times to kill all the vegetation, and then we had live or green plant vegetation. This image shows in the closer part of the slide, this was the dead plant material, and this is long-term no-till plot, so there's quite a bit of vegetation from last year, and you can see a few weeds from the current year, which happen to be common lamb squatters, Chenopodium album. I'm not sure if you even have that in Brazil, to be honest with you. Farther up in the slide, you see there is a tilled soil where there's just soil and there's no plant vegetation, compared to the green plant vegetation, which has much more surface area and so forth. And so we sprayed the same treatment, literally the same treatment over all three of these surface conditions. We have 3 years of data on this, but I just picked 1 year as an illustration. So this is from 2018. The blue lines at the top illustrate how much dicamba over time is collected in the tilled plots. And then the x-axis, we have sampling points at approximately 6, 12, 24, and 36 hours after treatment. So basically we spray first thing in the morning, and then about noon, we collect a sample. About nightfall, we collect a sample. We let the samplers run overnight, 12 hours, and then the next morning we collect a sample. And then the following evening, we collect a sample. So we have 4 discrete sampling intervals for the 3 surface conditions. And many of the field studies use a similar type of setup. The blue line represents the tilled surface condition. The red line represents the dead plant surface condition. And the green plants represent the green plants which were sprayed with the same dicamba. One of the surprising aspects we had was how consistently in all the studies, the dead plants always had about half of the amount of the tilled soil. And comparing the green plants to the tilled soil, we usually had about 3 times as much dicamba emissions coming from green plants compared to tilled soil or bare ground. So what you spray will matter with respect to how much dicamba comes back. The next question we wanted to look at was, do the new formulations volatilize? Which 3 years ago, that was the central question that we had. So we have a lot of data on this. And so we set up a trial with the 3 formulations I mentioned earlier, DGA, the Ingenia, and the XtendiMax. And most farmers in our market always have Roundup in the tank. They always have glyphosate in it to kill the grasses and so forth. So all of these are sprayed with Roundup in the tank. And that's a major important factor to remember. These are not sprayed by themselves. They always have glyphosate or Roundup in the tank. This is just a field shot showing our samplers in the field, soybeans, a mixture of weeds and so forth, long-term no-till. The study was conducted in 3 years, in 17, 18, and 19. The scales on the different years are quite different because the environmental conditions are very different. The red line is the DGA. The blue lines are the Monsanto with the vapor grip, and the green lines are the BASF with Ingenia. It's the same experimental setup with samples at 6, 12, 24, and 36 hours after treatment. Statistically, in 2017, the red line has a steeper slope than the other two. So you could say, yes, they're statistically different. But the reality is, what we see over and over again is the new formulations compared to the old formulations are more alike than they're different. This is not the result that we had hoped for. We had hoped that the new formulations would have no volatility. That's what I had hoped to see when I started the test, but that's not what the data shows. This is what our data shows, that the reality is the new formulations, when sprayed with Roundup, are more similar than they're different. The next field study to discuss, what is the effect of rainfall on dicamba vapors? We used a paired plot design which is basically the same treatment with yes and no, or with and without irrigation. We used the dicamba plus the vapor grip plus glyphosate on both plots, and the samples were inside the plot area. Now, I will say for these, we upgraded our samplers to a new water-resistant sampler, so my staff was very happy with our new samplers, which were much improved from the previous ones. And yes, the soybeans are very tall in this study. So looking at the data, the blue lines represent dicamba concentrations in the irrigated trial. The irrigation was applied 6 hours after herbicide treatment. So looking at the 0 to 6 blue line and the 0 to 6 green bar, those are basically the same treatment. But then an irrigation was applied, ½ inch, which is 12 millimeters, 6 hours after treatment, and that tremendously decreased the amount of dicamba emissions, as opposed to the green lines in the bottom, where there was much more dicamba emitted. And I think this has tremendous application that in Brazil, if there ever would be dicamba use, because if you have a rainfall every afternoon in your typical growing pattern, that could really reduce dicamba emissions in your situation. I really dislike doing humidome studies, but I was getting so much call for requesting data and so forth that I decided to take my samplers and start doing research under humidome conditions. So this is my version of the humidome, and as you can start from the left to the right of the image. On the left, we have a tray full of soil which has been treated or not treated with a chemical, dicamba, and little holes are cut in the very far left that allow the sampler to be drawing air in. The white tube in front of the large plastic tube is a Hobo temperature relative humidity sensor, so every single humidome has a sensor in it. The white where the plastic bag is, that's where the actual sampling media is, filter paper and then puff, and then the box on the far right is the actual sampler that is then vented out into the space. So this is what we call our humidome setup. And this is a tremendous amount of data in a single figure. So this is about 7 or 8 humidomes all put together. So the first bar, and this is the different temperatures, sampling intervals. So we have grouped them from the low temperature of less than 15 to the high temperature of greater than 30 C. And the temperature was allowed to fluctuate in the greenhouse and then measured over the sampling interval, which in this situation was always a 12-hour time interval. The gray bars at the top is the DGA plus vapor grip, which is just the XtendiMax alone. The middle bar, or the silver bar, is the same treatment with glyphosate. And the black bar is the DGA plus glyphosate. So when you just look in general at this data, the higher the temperature, the more dicamba was measured. And that's to be expected. Temperature, as you increase the temperature, it is expected that you would have more volatility at higher temperatures. It's a chemical process. The other aspect is that if you add the Roundup or glyphosate to the DGA plus the vapor grip, it increases the dicamba volatility. And that is also to be expected because of the pH effect, which we'll see in a minute. One aspect to it that I like to point out is that if you have the DGA plus VG, the gray bar by itself, at lower temperatures, 20 to 25 C, it is approaching very low volatility. So we were very encouraged by this data with respect to using that the DGA plus vapor grip alone at lower temperatures. But that's what we're seeing in our data. We then wanted to look at the pH effects on tank mixtures. These are all lab studies. We collected water sources with a pH from 4.6 to 8.3. I do not know what the typical pH of your spray water is in Brazil, but in the United States it varies substantially. And in fact, many times in many areas of the United States, the pH is quite high. It can be 7 or 8 very easily, given our karst limestone topography under much of our soils. So what we did was we made the mixtures, measured the pH, and if you read the label, the pH less than 5 indicates an off-label application. There was some disagreement with the registrants that it's not really off-label, but it's strongly encouraged to keep the pH above 5. So there's a reason that the 5.0 is a target on the labels. We first looked at Ingenia at 11 pHs. So at the bottom of each graph, there is a range of pH of source water from 4 up to 8.5. So that's the same on the left and the right graphs. On the left group of figures, that is the change in the pH from the original water by itself. So if we look at figure A, when we have a very low pH, adding Ingenia actually increased the pH 1 to 2 units. When we had, in figure A, when we had a very high pH to start with, adding Ingenia actually reduced the pH. The final pHs of those same mixtures is in figure D. So when you have whatever the water source is, in figure D, they're always well above 5.0 with Ingenia or BAPMA by itself. That was what we measured in the pH. Now, looking at the same data at figure B, what is the pH change? When you add the glyphosate potassium salt, it always tremendously reduces the pH from 1 to 2 pH units. And everybody kind of knew it would reduce the pH some, but I was really surprised by the level of and the magnitude of the pH changes. So looking at the figure E, the BAPMA salt plus the Roundup, again, much reduced pHs, and many are below the pH, the target pH of 5.0. There are some around pH 7, which were above 5, and that's an interesting observation, which we're basing on the water chemistry. While we're on this figure, we wanted to look at the effect of Intact, which is a commonly used drift reduction agent, and it had no effect on pH at all. When you add the Intact, it had no change in pH whatsoever. So that was the data on Ingenia, and the XtendiMax had very similar results. So I won't walk through all of the individual aspects to it, but it had very similar results with Ingenia. The vapor grip portion of XtendiMax is an acetate buffer system. So if you look at figure B, some of the pH changes were not as pronounced because of the acetate buffering system. But if your objective is to stay above 5.0 pHs and you look at figure E, many of those are below the target of 5.0. BASF and Monsanto-Bayer have addressed these pHs by having a website where you can go and look up pH modifiers that you can add to the system if you wish. The question we then asked is, many times people were adding other tank mixtures to the post-emergent Dicamba application for better grass control, for various other issues, for residual weed control. And so we added, starting at the top left, that was the Ingenia by itself, and the next one down is clethodim, next is glufosinate below that, the next down is glyphosate, on the top right is acetochlor, on the next one down is S-metolachlor, and the bottom right is bifenthrin, which is a pyrethroid. And our observations are that it doesn't matter what you put in the tank, the only thing that reduces the pH is glyphosate. And that was true with Ingenia, and in the next data slide, it's also true with XtendiMax, that basically the only thing that changes the pH appreciably is Roundup. So any type of residual herbicide or clethodim or glufosinate, when we get to that time later, or insecticides had no major effect on the pH of the spray mixture. So this is one of the XtendiMax slides, just as a recap, that we had when you have the XtendiMax by itself in figure D, all the pHs are above 5, and we would anticipate to have reduced volatility based on the pH modulating effect of the vapor grip formulation. In figure E, many of the pHs are below the target of 5, and it would be likely or possible to have enhanced volatility based on the addition of the Roundup. So let's kind of have some summary slides about what in general our results showed. We saw more dicamba from green plant material under field conditions. We saw similar volatility of new formulations to the old generic formulations. We saw temperature and spray pH affect dicamba emissions under humidome conditions. In a field study, the rainfall reduced dicamba emissions, and I would like to point out that that study was done in multiple states, and it was funded by the United Soybean Board. And results were more or less consistent that rainfall would reduce dicamba emissions. And our final point is glyphosate lowers spray pH, which could have an effect on subsequent volatility. Now I want to leave the data that I have developed over the years, and I want to now go into a point about just what we're seeing in the United States. And the first idea is what we call dicamba fatigue. And because in our system, the state inspectors often have the responsibility to go and investigate any kind of off-target movement. And there's been an increased workload on many state inspectors. And unfortunately, because of the difficulty of analysis and of identifying the source, there's been a lack of closure in many cases. There are cases from 2017, 2018, 2019, and many of them are still not fully resolved or decided at this point. The dicamba use has had an emotional response from non-applicators, people who live near the fields and their gardens and their trees have been in times very emotional and very problematic. The state regulators and the extension agents in our system and the scientists, they have a lot of other things to do besides all these dicamba calls in the middle of the summer. And all those calls take away from their other important duties, being a state inspector. So as the years have gone by, what have been the results of this dicamba fatigue? Well, many farmers just stop reporting it. And so one of the reasons why our number of complaints are down in some states is because the farmers stopped reporting it, because they reported in 17, they reported in 18, and nothing happened. So they just stopped reporting it. In many markets, the farmers changed to extend our dicamba tolerant varieties as insurance. In Tennessee, our market share of dicamba tolerant varieties of soybeans is about 95% in our main soybean growing area. And in cotton, it's about 90% too, because they didn't want to have to deal with their dicamba damage from their neighbor. It's just a neighborly thing to do. Unfortunately, the chemical trespass is still occurring, and the dicamba is still moving. So in a way, we've addressed the soybean problem, but we really haven't addressed the gardens and the trees and the natural areas. So now as I go into closing thoughts, I do want to just mention that there has been a court decision in the United States that vacated the new dicamba labels. And I think many people are uncertain about the immediate effect of this court ruling. And as such, I will say nothing about the court ruling. As I've just been working on the dicamba topic, I have gotten the privilege of working with the United States Environmental Protection Agency staff. And the more I work with these people, the better I think of them. They are hardworking, honest people with absolute integrity who are doing an excellent job under a very difficult circumstance. And so I have nothing but fantastic words of praise to say for the entire US EPA all their staff, and everything, because they've been put into a very difficult position to weigh the benefits of this technology, because we have very real glyphosate resistant weeds. We have very real situations where palmer pigweed and water hemp are very real agronomic problems in the United States. And that's a huge benefit of all the dicamba technology. That being said, there is some data, such as I've shared today, that there may be some off-site movement. And trying to weigh those two counterbalancing forces has been a challenge. And but the take-home message at the end of the day is I have nothing but praise to say for the EPA staff. One of the aspects of how they do their business with the EPA is that their statutory authority says that they have to have a 10% height reduction level, and that's their trigger to make their regulatory decisions. And that's why they have to do their job, in my interpretation. This is a very general way of looking at it. Well, unfortunately, 10% height reduction, there's a lot of visual symptomology of dicamba that happens before we get to that height reduction level. So in closing, how do you stop dicamba volatilization? Well, you really cannot stop it completely, but you can spray at lower temperatures, and you can spray, you do not add Roundup to the tank. So there's a couple of very real things we can do. And you can accomplish number 2 and number 3 by spraying earlier in the season in the United States. This will put you at lower temperature and less plant material. The other way is how to stop dicamba volatilization is don't spray dicamba, which is perhaps one way to go. I'd like to acknowledge that this research is funded by the Tennessee Soybean Promotion Board and the United Soybean Board. I have an excellent technical staff of Kinzer, Beeler, and Clark, and several student workers. And I want to invite you to always read and follow all label instructions for all crop protection products. Dr. Camargo, I stopped share.
No, you can stay. No, leave it there. No problem.
Good.
Thank you, Dr. Tom Mueller, for your excellent presentation. We're gonna go now for the answering questions and answers section here. See what we have. So can you hear me okay?
I can hear you fine, Ed.
So Bob Bruss asked, if you irrigate 6 hours after application, is this enough time for the weed to absorb the dicamba? Were there any observation on plant residues on weed control?
Do I need to repeat the question, or since you're reading it, I don't need to repeat it, right?
No, you don't need to.
Auxin herbicide uptake is normally fairly rapid, and I would say 6 hours would be enough to get adequate uptake. The plots were weed-free plots, so there was no weeds present in this particular plot, which is soybean canopy. And there was no plant residue collected from these particular plots. We have other studies that we are collecting various herbicide residues and analyzing them. So in a research setting, you set it at 6 hours. So that's why we picked 6 hours. It's just long enough to allow it to get into the plant and then wash it off. In an actual farming situation, it might be 12 hours or 24 hours. Ed, do you think that's answered the question?
Yes, I think it did. The next one from Diana Zabala. She asked, in the experiment, vapor pressures of the formulation are different? The vapor pressure of the formulations?
The actual, okay, the driving force, well, first off, there's very different ideas about how this movement of the dicamba molecule from the solid into the atmosphere occurs. So I want to say the most important thing to say is we're not really sure, and I don't know, but in general, the acid formulation, the dicamba acid is more or less considered, that's what's going to move into the air. So you've got to get it to the acid, and that's what actually volatilizes that. Not all people believe this. This is just one idea. And so if you look at the strength of the association of the various amines, the dichloroamine, the batmamine, how that interacts with the dicamba acid will determine how much volatilizes up in the air. Vapor pressures of the formulated products in water are very difficult to measure. So I would like to answer the person's question by saying I do not know how the vapor pressures differ, and the different amines clearly have an effect on the volatility, but I can't say that the pKa of dicamba acid is 1.87. I mean, everybody knows that. It's about a little below 2. But what they are of the formulated products, I don't know. Another thing is it's always in water, so it's dissociated anyway. So it's a very good question that I wish I had a very nice, precise answer to, but I do not have that answer.
Okay, thank you. Another one from Martin Ayub. Have you seen antagonists between dicamba or 2,4-D when mixed with CCase inhibitors? Does this increase dicamba volatilization?
Yes, Dr. Larry Steckel and I have done many projects looking at the antagonism, and yes, an auxin will always antagonize an ACCase inhibitor, and so yes. What was the second part? Oh, we have not directly measured the effect of the ACC on the dicamba volatility. We have measured the pH effect, and there's no major pH effect. So our hypothesis would be that it would not have a major effect on the dicamba volatility, but the ACCAs would have minimal effect on the dicamba volatility. The dicamba is greatly affecting the ACCA's activity, and we see in our observations is that the great next wave of problems is grass weeds in our soybeans and cotton. That's the next big problem, is grass weed. Very good question.
Mm-hmm. Thank you. Well, I don't have more questions for the audience. I have some questions of myself for you, and a few of them actually. If you have time, I would like to touch on those. I think that you present the data on nanograms. All that those numbers are in very small amount that you are able to quantify. How is that related with the percentage of the amount that you spray, that you are capturing in the air?
Yeah.
So
yeah,
the audience will have an idea of what we are talking about.
Yeah, always it's a very low percentage. It's going to be approximately 5 or 6 orders of magnitude less than applied. When you capture the vapor in this situation, you're at less than 0.001% of applied. So it's a very small amount. And the objective of my study is what is the relative, like let's say we look at the different formulations. What I was looking for is what is the relative volatility of the new formulations to the old formulations. Because we have decades of history with the DGA clarity. I mean, we have decades of history of how that works. And so that's why my studies are based, it's really more of a relative idea. But it's, as far as an absolute percentage, it's a very small percentage. In fact, the Monsanto people just published a paper looking at modeling flux, and they said it's always less than 0.2% of applied. And that's a true number, but based on the sensitivity of some species, the dicamba, 0.2% of applied is still more than enough to cause an off-target movement problem. Mm-hmm. Does that speak to your question?
Yes, and kind of relate to what you mentioned too, as the farmers are buying the seed so they are safe from their neighbors. When you, my follow-up question would be, when you have a lot of product apply, how do you see the problem with other crops other than cotton and soybean?
Well, dicamba on corn is not a problem. It's because it's labeled on corn. So, and we in our market situation, we really don't have any other major crops. Tobacco is quite sensitive to dicamba, but our tobacco acres are greatly reduced over the last decade. But we have had some tobacco lawsuits, And there was also a very widely publicized peach trial in Missouri, I think it was. So there's a lot of off-target movement. It's a lot of nursery crops, vegetables. In Indiana, tomatoes is a major issue. So there's some challenges in that way.
Okay. I have also new questions here from Dr. Hudson Taken. He had two questions. I will ask one and then you can answer and we'll go to the next one. What's your perspective on dicamba use in tropical countries like Brazil?
On the one hand, I think it could be very problematic because you have warm temperatures and conditions very conducive to volatility. You also have very large fields. So on the one hand, it would be very problematic because you're going to have all this energy that's going to make the volatility be great. But if it rains every afternoon, and when I was in Brazil, it seemed like it rained a lot of afternoons. I mean, you know your weather better than I do. If it rains every afternoon, that's going to really decrease the volatility. And it's because that's clearly once it gets rained in, it's not going to be as volatile. I would say my understanding of your broad acre soybean or cotton fields, if I've got 100,000 hectares in a unit that's all going to be the same XtendiMax or dicamba tolerant, that'd be a great opportunity. The whole sector, the whole county, whatever your unit is, those 100,000 hectares are all going to be dicamba. But what we've seen is that there's a potential for landscape scale movement. So if my 100,000 hectares is adjacent to another 100,000 hectares that's glufosinate tolerant or just Roundup tolerant, and that the dicamba can move from the one treated area to the non-treated area and could be very problematic. So that's the two ways of looking at it. It's bad because you're hot and a lot of volatility, but if it rains every day, it could reduce the volatility. Does that speak to the question?
Yeah, I think it does. The other question is, in your studies, was VJ added to the DJA or did you use extended formulation?
I use the extend formulation straight from the manufacturer.
Okay. Another question, Luis Henrique Zabioli. What is the minimal output volume that in U.S. farmers can spray using the new dicamba formulation?
You mean as far as the carrier volume?
Yeah, the carrier volume.
I'm not sure. I'd have to read that.
Does that change the attributes of the formulation if you go too high or too low?
In the pH paper, and I'd advise him to look at the paper. He can look up the paper which is published in Weed Technology. It's something about, it's in the like in last year's Weed Technology. We had 3 carrier volumes in that study, kind of like a low, medium, and high levels of carrier volume, and the pH at times had effect, but it wasn't a major effect. So I would ask him to look at that paper, and that will address that exact topic.
Okay. All right, thank you. I have I think I taken all the questions for the audience. Regarding to glyphosate, do you think the only the pH change explains the change on dicamba volatilization? Is that the only player on that? When you add the glyphosate, you have a higher volatilization?
I would say that based on our data, you cannot answer that question fully because we have used commercial formulations because that's what a farmer is going to do. So we try to keep our research to be as relevant as possible. So we're using commercial formulations. The pH modulation of Roundup is a substantial issue, but there's going to be there's surfactants in there and so forth. So it is based on our studies, I cannot answer the question. But I can say that the pH was a major change in our system. But yeah, I would say that there would be potential for a surfactant effect or something other effect would be fine, would be possible.
Okay, that goes along with the Gustavo question also. if you had done any studies with adjuvants to see if that will reduce volatilization of dicamba.
Yes, we have done studies with adjuvants. That is proprietary, and I cannot discuss that data.
All right. I think we have taken all the questions. Once again, we appreciate Dr. Mueller for your time, for preparing the data for our discussion here. I would like to invite people to stay tuned. For next week, we're gonna have this webinar series will continue with Dr. Richard Napier and Dr. Todd Gaines. Those webinars will be on June 17 and June 18. So thank you, Dr. Mueller, again for your time, and we wish everybody to stay safe.
Até mais.
Bye-bye.
Bye-bye.